Imagine a flood so vast, so powerful, it could sculpt entire mountain ranges, carve canyons hundreds of feet deep, and reshape continents. These are not mere deluges. These are megafloods. They are colossal, unprecedented water events of unimaginable scale and destructive force. Megafloods have reshaped Earth's landscapes, leaving indelible marks that speak of their raw power. They offer a profound testament to the dynamic forces at play on our planet. Their impacts dwarf even the most devastating modern floods. These cataclysmic events are often triggered by equally catastrophic phenomena. Glacial outbursts, when massive ice dams suddenly fail, can unleash unimaginable volumes of water. Even asteroid impacts and immense volcanic eruptions can play a role in their formation. These ancient deluges demonstrate the sheer power of water as a geological agent. Studying them provides crucial insights into Earth's turbulent past. They remind us that our planet is a place of constant, sometimes violent, transformation. During the last ice age, an enormous ice dam repeatedly formed and broke in what is now Montana. This blocked the Clark Fork River, creating the vast glacial Lake Missoula. When the ice dam failed, it unleashed a colossal torrent. These repeated Missoula floods scoured the landscape of eastern Washington state. They carved out the distinctive channeled scablands, leaving behind dry coulees, towering waterfalls, and gigantic current ripple marks on the scale of hills. The sheer volume of water released remains astounding. Around 450,000 years ago, and again much later, a series of megafloods carved out the English Channel. Geological evidence suggests that a massive proglacial lake, trapped in the southern North Sea basin, breached its natural dam. This dam was likely a chalk ridge, connecting Britain to continental Europe. The catastrophic outflow of water created a wide, deep valley, eroding the land bridge. This immense deluge separated Britain from mainland Europe, fundamentally altering regional geography forever. It turned an inland region into the island nation we know today. The Black Sea region holds a fascinating and controversial megaflood theory. Around 7,600 years ago, the Black Sea was a freshwater lake, significantly smaller and lower than it is today. A natural sill separated it from the Mediterranean Sea. As post-glacial sea levels rose, this sill is theorized to have catastrophically breached. A massive influx of salt water from the Mediterranean cascaded into the Black Sea basin. This transformed it from a freshwater lake into the saline body of water we know today, potentially displacing human populations. While not on Earth, the Red Planet provides compelling evidence of colossal megafloods. Vast outflow channels and streamlined landforms on Mars clearly indicate past catastrophic water events. These features are remarkably similar to Earth's channeled scablands. Scientists believe these Martian megafloods originated from immense subsurface water reservoirs. The water was likely released rapidly by tectonic activity or volcanic heat. These deluges carved vast canyons and shaped the planet's surface billions of years ago. In present-day Utah, around 14,500 years ago, ancient Lake Bonneville was a vast freshwater body. It eventually overtopped its natural rim, the Red Rock Pass, near what is now Preston, Idaho. This event triggered the catastrophic Bonneville flood. The rupture unleashed an incredible volume of water, flowing north through the Snake River. It carved the impressive Snake River Canyon in Idaho, deepening it dramatically. This megaflood also deposited vast amounts of sediment and sculpted landscapes across thousands of square miles. While not a conventional water flood, the Siberian Traps eruptions represent a period of immense geological upheaval. This massive volcanic event, around 252 million years ago, released staggering volumes of material, including gases that altered Earth's atmosphere. The intense volcanic activity would have vaporized vast quantities of frozen water, and melted extensive ice sheets. This likely resulted in widespread torrential rainfall and massive runoff, contributing to extreme hydrological changes. These effects potentially amplified the devastating Permian-Triassic extinction, Earth's largest mass extinction event. The Zanclean flood marks one of Earth's most dramatic hydrological events, occurring about 5.33 million years ago. It ended the Messinian salinity crisis, a period where the Mediterranean Sea had almost completely dried out. The Straits of Gibraltar were closed, isolating the basin. When the Atlantic Ocean finally breached the Gibraltar land bridge, an enormous cascade of water refilled the Mediterranean. This mega splash event lasted for years or even centuries. It dramatically altered the Mediterranean's salinity, climate, and ecosystem, restoring it to a thriving marine environment. Around 34 million years ago, Earth experienced a significant climatic shift. This period, marking the Eocene-Oligocene boundary, saw a rapid global cooling and the expansion of polar ice sheets. This dramatic change in climate had profound effects on global hydrology. The growth and collapse of ice sheets likely led to widespread, large-scale flooding across continents. These events reshaped coastal landscapes and river systems. Such widespread deluges played a role in influencing the evolution and distribution of life during this transitional period. Coinciding with the end of the dinosaurs, the Deccan Traps in India erupted on a colossal scale around 66 million years ago. These massive volcanic eruptions released enormous volumes of lava and atmospheric gases. Their impact was global, contributing to climate change. The heat and geological upheaval from these eruptions may have triggered catastrophic meltwater floods. These deluges would have dramatically altered local and regional hydrology. Such megafloods likely added to the environmental devastation, leading to the Cretaceous-Paleogene extinction event. During Earth's earliest history, approximately 4.1 to 3.8 billion years ago, our planet endured the Late Heavy Bombardment. This was a period of intense asteroid and comet impacts, leaving its surface heavily cratered. These impacts had profound effects on the young Earth. The energy from these impacts, combined with widespread volcanism, would have vaporized existing oceans and then caused torrential global megafloods as the water condensed and rained back down. These cataclysmic events were crucial in shaping early Earth's oceans, atmosphere, and crustal formation. From ancient Earth to modern Mars, megafloods reveal the dynamic and often violent nature of planetary history. Their scale reminds us that geological forces operate on timelines and magnitudes far beyond human experience. We can still see their scars across the landscape. Studying these colossal deluges provides valuable insights into the powerful forces that shape our planet. They teach us about glacial cycles, tectonic movements, and the extreme impacts of climate change. Each megaflood tells a story of transformation and immense power. Ultimately, the study of megafloods is a powerful reminder. It underscores the incredible power of water to sculpt and reshape landscapes on a truly grand, almost inconceivable scale. They are Earth's ultimate hydrological spectacles,